join us. Okay. Okay. Shall we start? Shall we start?
Yes, sir.
Okay. Right. So we're going to start from where we stopped on investment appraisal. Last class we dealt with payback period method and accounting rate of return. Okay. Those are the two initial methods that we look at when we are doing our investment appraisal. And just like we've seen them, they are easy bits. They are easy to calculate. The only problem with them is we don't use them entirely in our investment decision making. So we only use the two methods as an initial screening process. Okay. So today we're going to look at the DCF techniques, that's the discounted cash flow techniques, which is, of course, the best technique in analyzing long-term investment, in appraising long-term investment. Okay. So on the DCF techniques, there are three main topics. That is the discounted payback period. Like I said, we're not going to do that because it's the same as payback period. You know, the only difference is the cash flows that relates to the future are discounted to their present values. So since we're going to do that when we're doing NPV analysis, so the discounted NPV, sorry, this discounted payback period, we're not going to look at that. Then we're going to look at NPV in details. We have an exam type question that we're going to do. It was a past ACCA question. And then we'll look at IRR, and then that will be the end of it. Yeah, that will be the end of it. Right? So we're going to start. Now, before we look at the NPV method and the IRR method, we're going to look at two tricks, two methods. That's the terminal value, which is feature value. You get your feature value by compounding. So we're going to look at compounding and discounting. Yeah, so discounting is when you have future cash flows. When you have cash flows in the future, you want to bring them to their today value. Okay, which is what is going to be used in our DCF techniques. Okay. So we're going to look at terminal value calculation, which is compounding. Okay, I'm sure you've looked at compounding before. you've done some compound interest calculation in your previous studies, yeah? So what compounding means is if you have a cash flow now and then you want to invest it for future, what will be the value of that investment in future? For example, if we invest £10,000 now with an interest of 10%, what will be the value of this interest in 1 year time? What will be the value of this investment in 1 year time? And what will be the value of this investment in 2 years time? So that's what we call compounding. Okay, I'm sure we have done some compounding before. We use a formula which is called V is equals to X into 1 plus R raised to power N. Okay, in this formula, V is the future value which you are trying to find. Okay, you're trying to find the future value, that is V. How do you get it? You get it by compounding today's value with the interest rate and for the number of years. So X is the value for today's value into 1 plus R, okay? 1 is a constant and R is the interest rate. For example, if you have an interest rate of 10%, that will be 0.1. So 1 plus 0.1, okay? And N there is the raised to power N. So N is the number of years. Okay? So this is what we do in compounding. I think we are all used to this. We've done this before. One thing I have, yes.
Is this going to be like the same as like if you find in the future value, like when you say future value is equals to the present value, open bracket 1 plus R close bracket to the power N.
Yes, to the power N, yes. So that's what you want. So the V there is the future value, okay, which you are trying to find, okay? Why you're finding it, that's the reason why you are compounding. So you are compounding using the interest. So what are you compounding? You are compounding the today's value, okay, with the interest for X number of years. So that's why you have V is equal to X into 1 plus R. R is the interest rate raised to power N, okay? So that's the way you do your compounding. I think I don't know of some of you who have went through this middle school, senior school system, but for us who've gone through the common entrance system, we used to do this in primary school, compound interest. Okay, so it's a simple thing. Okay, so in order for you to be able to do your compounding and your discounting, you need a scientific calculator. Okay, so please take note, you need a scientific calculator. That's really, really important, especially your Casio scientific calculator. So in exams, you can't go to exams without a scientific calculator, okay? Because in exams, the discount factors will not be given to you, so you have to calculate them, okay? So if we want to calculate the value of our investment in how to call it, in a year's time, the investment now is 10,000 and the interest rate is 10. So what you do is, what you put in the calculator is you press 10,000 multiplied by, okay? So if you're having scientific calculator, can you do that now? You put in the calculator 10,000, okay? Then you do the multiplication, okay? You open your bracket. Scientific calculator has a bracket, okay? So when you open your bracket, then 1 plus 0.1 is the same as 1.1, okay? So do your 1.1, bracket closes, okay? And then the raised to power in some calculators is denoted with y, and then you have x on top of y in some older scientific calculators. But in newer scientific calculators, is denoted with like a v, sort of like a v. Okay, so if you press that v and then you press 1, that should give you 11,000, like that. And if you want to find the future value for an investment of £10,000 now with a 10% interest in 3 years, so do the same thing, 10,000 in the calculator, then you open your bracket, 1.1, close your bracket, then you do that raised to power 3 and you press equals. Okay, has anyone done it? Has anyone done it yet?
It's 92.61.
I got
92.61.
I got it too.
Which one are you doing, Roger? The year 1 or the year 3?
Year 3.
Okay, you took 10,000 multiplied by bracket opens, 1.1 bracket closes, raised to power 3, then you press equals. You say how much you got?
13 point. Let me do that again.
13,310.
13,300. That's what.
It's 17 hours.
That's exactly what you should get. Okay. That's exactly what you should get.
I didn't get that.
Huh?
No.
Yeah, I got 13,300.
10,000.
Yeah, so what you do, Roger, is type 10,000 in your calculator, then you say multiplied by, open brackets. On your scientific calculator, there should be bracket open.
Yeah.
You type 1.1, close bracket, then press that sign that looks like either a V or Y raised to power X. I think in newer calculators, it's denoted by a sort of not a V actually. It's
Yeah,
the reverse of
I got it. I got it. I got
you
it.
got it
I got
now.
it.
Good. Okay.
Yeah, 13.310.
That is it. Okay. So actually, it should be 13,310, not 13 point. 13,310. Okay. So that's the way you do your compound interest. Okay. Can you try 200? 200, the terminal value of 200. So if you invest 200 now at an interest rate of 7% for 10 years, can you do that? How much are you going to get? So what I'm going to do is, yes, you got it?
For how many years?
For how many years?
For 10 years.
For how many?
10 years. 10 years. The one in red.
I don't know if I'm correct. 393,430.
I got 518.7.
No, it's 393,000. Yeah, 390.
No. It's not 200,000. It's only 200. Look at the question. Look at the question here in red.
It's 393.
393, correct.
Yeah, that's what I got. 393,430.
No, it's 393. It's 390. The other one is 0.430 and stuff like that.
Yeah. 0.430. Yeah.
Yeah, when you round it up, it's 393.
There's no electricity around, so obviously I'm finding it very difficult. Hence, I'm using magnifiers. You know what I mean? So you have to excuse me.
Rosa on that, don't worry. Okay, we missed you on the last 2 classes, but anyway, I mean, all the videos are uploaded, so please, for those of you who missed those classes, you can easily find them, yeah?
Roger that.
So all the videos that all the classes we have done, I have uploaded all the videos. Sometimes I'll stay awake until around 1 to make sure that the videos are uploaded. So if I'm making efforts, please try to make efforts.
Even if one is angry about you, the moment you start talking, the person will forget about the anger. You know, you are a real gentleman. So that's the beauty about you. So no one can hold grudge against you.
Okay. Thank you, Rosa, on that. Okay, right. So I think we can move. We will not use compounding much actually, but we'll use the opposite of compounding, which is discounting. Okay, so we're going to use discounting. So let's look at discounting. Okay, I'm going to open a new worksheet. I'll be using Excel to calculate. I'll be using Google Sheet to calculate. But then you can use your scientific calculator. Okay, so discounting, as you can see here, is the very opposite of compounding. Okay, when do we compound? We compound when we have today's value and we want to see how the value is going to be tomorrow, or in the next 10 years, or in the next 50 years. That of discounting is we will have, cash flows in the future. We want to bring them to today's value. Okay, so this is what we will be doing in our NPV analysis and IR and our IRR. Okay, so it's nothing but the very opposite of compounding. Okay. So that's why when you look at the formula you don't have to remember it much. It's just the very opposite of the compounding formula. In the compounding we have how to call it, V is equals to X into 1 plus R raised to power N. So what we do here is we try to make X the subject of the formula, with our little math that we learn. So if we want to make X the subject of the formula, what do? So you say X into 1 plus R raised to power N equals to V. You can transpose it in any way, mathematically, yeah? So you can say V is equals to X into 1 plus R raised to power N. Equally, you could say X into bracket 1 plus R raised to power N equals to V. Okay? So if you want to make X the subject of the formula, you could, X into bracket means X multiplied by whatever. Okay? So if you want to find X as the subject of the formula, so what do you say? You will say X equals to V divided by 1 plus R raised to power N. So that's exactly the formula for discounting. Okay?
Say that again, the formula for discounting.
Yes, the formula for discounting, I said discounting is the very opposite of compounding. Okay? If you compound, what you're trying to do is you're trying to find the future value of an investment now. Okay? If you're discounting, you're trying to find the present value of a future cash flow. Right? So in our formula for compounding, we have what? V is equals to X into 1 plus R raised to power N. V is the future value that we look for when we are compounding, whilst X is what? Is the value now. 1 is the constant, plus R is the rate, and N is the number of years. So if we're going to do the discounting, instead of V is equal, we will say X is equal. So that means we are going to make X the subject of the formula. Okay, so to do that, we say X into 1 plus R raised to power N equals to V. Okay, if you say that, then if you want to find only x now, x will be equals to v, instead of multiplied by 1 plus r raised to power n, it will be divided by, because x into bracket 1 plus r to power n means x multiplied by. I think we all know that mathematically. So when we want to find x, the subject of the formula, this multiplied by will be divided by. So that's why you will have x is equals to v divided by 1 plus r raised to power n. Okay? That's exactly what we have for our discounting formula. Is that clear? Is that clear?
Yes, sir. Yes, sir. So that means the division has to be before the bracket open, right?
Yes. You know, I don't know whether we did. Well, everybody here, I guess, must have done math, because you have to have a credit in math before you can do this. You know, there is a change of there's a subject called change of subject in mathematics. So you apply the same concept here. Change of subject. I think we've all done it before, isn't it? Yeah. So yeah. So you will do a little change of subject, because if you don't have that knowledge, maybe your best bet will be to memorize the formula, and it's not good to memorize formulas. If you memorize
like this in management too.
Sorry?
We did something like this,
In management accounting too. Okay, good, very good. Okay, good. So that will be like a revision for you. Okay. Right. So now we're going to look at discounting. Okay. I told you how you can arrive at the discounting formula. So let's look at how we do discounting, and then how we arrive at our discount factor. Okay. So I think this particular work has been shared with you yesterday. So just make sure you turn to that page where we have discounting, or you can screenshot this, because I'm going to turn to Google Sheet so that we can do the calculations. Yeah. Okay. Right. So I'm going to open my new spreadsheet. I go to plus sheet. Excellent. So I'll stop projecting this. Then I will project. Right. Share. Okay. So this is the new spreadsheet that I've opened. I'm going to magnify it to 150. Okay. So this is what we are going to use for all our DCF techniques. So I'm going to call it discounted cash flow techniques. DECHNIQUES. Okay, so I'm going to call it DCF techniques, discounted cash flow techniques. Okay, so the first sheet, I'm going to name it discounting. Okay, I'm going to call it discounting. Okay, are we together? Are we together? Okay. So, like I said, discounting is the very opposite of compounding. So that means if you have a cash flow, of 11,000 that is supposed to accrue after year 1, if you want to bring that to today's value, okay, if you want to bring that to today's value, what are you going to do? Okay, at least for now, we know that we have to apply our formula. And our discounting formula, I'm going to write it here. Okay, so our discounting formula is what?
Mr. Fofana.
Yes.
Sorry, it's me, Mari. My laptop is not going, so I'm using Mohammed's one.
Okay.
If you want to use your phone, I want to access this on my phone, but I couldn't.
You want to access the slides, is it? Or the spreadsheet?
No, yes.
You have to download the app, Google Sheet app. You need to download. That's the problem. But what you can do is, you know, just do it, you know, manually. Just do it manually. Then maybe after class you can how to call it? Try to practice. You know, especially after watching the video. Yeah.
Okay.
Yeah. Because if you want to download it, that will take time. For phone, you have to download the app on it.
The Google Sheet?
Yeah, the Google Sheet app. Yes, the Google Sheet app. You have to download it on it.
Okay.
Right.
No problem.
Okay. So shall we?
I'm seeing different ones.
Okay. Right.
But I'll do that after.
Yeah, you can do that. You can do that after. Okay. Okay. So we say X. So we say, are we together? Hello?
Yeah.
So X is equals to B divided by 1 plus R. R is the rate. Bracket closes, raised to power N. N is the number of years. Okay? So if we have a cash flow for year 1, say 11,000 pounds. Okay, 11,000 pounds. I'm going to take that to 2 decimal place. Okay, and then I'll only need the 1,000 separator. I'll remove the decimal places. Okay, right. So the A part of the discount, that's the question just below the discounting. Okay, so that's 11,000 after 1 year, 12,100. So we have 11,000, 12,100, and we have 13,000. So this is like the one we did when we were compounding. So we want to discount them now. Okay. So those of you that are using scientific calculator, so what you will do is you will say 11,000. You type 11,000. Okay. After typing 11,000, you say divided by. Then you open your brackets. Okay. Follow me, please. You open your brackets. Okay. You open your brackets and you say 1.1, bracket closes. Okay, so that sign, like the reverse of V, so you press that and you say raised to power 1, you enter. So that should give you 10,000.
Yeah, Mr.
Okay.
Fofana, I get 10,000.
Excellent, good. So that's year 1. I'll do year 2, year 3 here. So I'll format this. Okay, make sure everybody you get 10,000, yeah? Discounting, you must be able to do it. That one came on is a must because there is a question on it in the exams. So please don't say I'm not giving you any tip, but I'm already telling you that there will be a question on investment appraisals. So you must be able to know how to do discounting. So I'll repeat that again. For those of you that are having scientific calculator, okay, So I'm using Excel, but in exams, you are going to use scientific calculator, okay? So you say, you type the 11,000, okay? For me, I've got 11,000 already typed. You say divided by, you open your brackets, and you say 1.1, okay? Bracket closes, and you say raised to power. Okay, raised to power, for me, it will be raised to power 1. That will be 10,000. Then when I replicate, okay, so 10,000 for all of them. So if you do that, for year 2, it's going to be raised to power 2. And for year 3, it's going to be raised to power 3. Okay, please make sure before we proceed, make sure you are able to do this on your calculator. It's important to know how to do it on Excel, but it is really, really important to be able to do it on your calculator, since you are going to do it using your calculator in exams. Okay, are we good to go?
So there was no electricity. The electricity went and just came back. If you can please go back a little. Thank you.
You know, electricity is not supposed to go out at Hamza Barak, huh?
No, I'm at defense headquarters right now, because even the signal at Hamza Barak is the poorest, in fact.
Wow.
No signals. So I have to come to defense headquarters to attend these lectures.
Wow, okay. Okay, I'll go over it again. So you're all set. So we are trying to do a discounting, okay? So we've all seen that this is the formula for discounting. Okay, so I'm gonna make it big. In discounting, what do we look for? We look for today's value. Today's value is denoted with X. Is equals to V is the future value divided by 1 plus R. R is the rate, the interest rate. Bracket closes to the power N. N is the number of years. Okay, so here, this will be our M, and this will be our V. Okay, so we can even do our rate here somewhere. We can say our R is equals to what? 10%. So I'll format this to percentage, and then I'll say 10%. Okay, now I'll do everything here. So if you are using a scientific calculator, please listen to me again. You will type 11,000. Okay, type 11,000 divided by, bracket opens, okay, divided by bracket opens, 1 plus the rate. Okay, the rate is 10%. Okay, so in my case, 10% is typed here, so I just click on this. Then I make it absolute. I close it. Then I say raised to power 1 for 1 year, I enter. So that gives me 10,000. So once I replicate, it's 10,000 for all of them. So for the second one in your own, yes.
For the second one, I didn't have 10,000 with my calculator.
Okay, for the second one, what you do is you say 12,100 divided by.
It's 12,000. I thought it's 12,000.
No, 12,100. 12,100. Look at it. Can you see what I'm?
Yes, I didn't see the 100.
Oh, okay.
Yes, I just saw the 100.
Yes, yes.
Thank you.
Right. So that's 12,100. Okay. So this one is 13,310. Okay. So that's the way we do our discounting. Okay, so this is discounting using what? Using the formula. But you know, accountants, we are, you know, lazy mathematicians. So because we are lazy mathematicians, we would like to make, you know, mathematical functions easier for us to manage. So we say, okay, we cannot do all this. What we want to do is we just want to have our future value and multiply it by one number, and then boom, we have our current value. Okay, so because of that, the accountants went in for what we call a discount factor. Okay, what we went for, we call it what? A discount factor. So, but when you look at the discount factor, it's the same. They've derived the discount factor from this function. From this function. Okay, so we can take one of these examples here. For example, let's say the second year, 12,100. Okay, in order to get our 10,000, what did we do for the 12,100? We said 12,100, okay, divided by 1.1 bracket closes raised to power, sorry, let me just do that again. So we say 12,100 divided by 1.1 bracket closes raised to power 2. I think this is what we did, isn't it? Okay, this is what we did.
Yes.
Okay. Right. So we enter, then we had our 10,000. Let me just copy this. I'm going to show you this. Sorry. 1 second, just copy that. This was the formula we had on here. Okay, forget about the equals. The equals, you need it for all the formulas for Excel. This 12,100 divided by 1.1 raised to power 2. Okay, is there any way of doing this again? And I mean, mathematically, and it will be correct. This 12,000 divided by is 12,100. Is it not the same as 12,100? Is it not the same as 12,100 divided by 1? Okay, multiplied by 1 divided by 1.1 raised to power 2.
It can also be 12,100. 12,100 over
1
over 1 plus r in bracket to the power n.
Yeah, but what I'm saying is mathematically, this expression here, 12,100 divided by 1.1 raised to power 2 is the same as, when you break this, 12,100 divided by 1 multiplied by 1 divided by 1.1 raised to power 2. Is it not the same?
Yeah, it's the same.
It's the same. It's the same. And if you say 12,000 divided by 1, is that not 12,100 divided by 1? Is that not 12,100?
Yes.
Okay.
Yeah, it is.
Then now we say multiply by this. And the one we are multiplying by is what we call discount factor.
Mr. Fofana?
The way you can derive your discount factor. So this something here, this is what we call our discount factor. So now instead of doing all this 12,000 that divided by that, so you only have your 12,000 multiplied by your discount factor, and this is your discount factor. So when we are doing our discounting, we have our cash flows, our future cash flows. We look for our discount factor and we multiply them. We multiply the two together. The only is just the same as you using this formula. They've derived it from that formula. Okay? Yes, somebody wanted to say something?
Yes, Mr. Fofana.
Yes, Mary.
Yes, I did 12,100 divided by 1. Then I said divided by 1.1 to the power 2. To the power 2, and I got 10,000 as well. Does it mean that that one also is correct?
It's also correct, yes. You know, this is maths. You can do it in any way, and then it will still be correct. Okay.
Okay.
So, but this is the way they arrive at a discount factor. So this is your future cash flow, and this is your discount factor. So this is your DF, and that's your how to call it future value. Okay. So this is exactly the way they arrive at our discount factor. So let's look at the 4.2.1. Okay, so we can just use a discount factor. So easily, that means if you want to do a discount factor, what you do is, I'll go up now. So I'll go up now. Then I'll have cash flow. Future cash flow. Okay. We'll have our discount factor. Then we have our present value. So, what numbers did we get? These were the numbers we got. So just copy them. I paste them here. Okay, so now let's do our discount factors and then we multiply. So on your calculator, do 1, just type 1 divided by, bracket opens, 1.1, close the bracket, then you use the V in its reverse form, 1, then you enter. Okay, so once you enter, you should have something like, by default, discount factors are usually taken into 3 decimal place. So you express it into 3 decimal place. So we do the same thing here. In your calculator, use your discount factor. 1 divided by, bracket open, 1.1, close your bracket, raised to power 2, you enter. See, you start 0.826. Then you say again, 1 divided by, bracket opens, 1.1, bracket closes, raised to power 3, you enter. Okay, so this is the way you calculate your discount factor. But I'll show you a shortcut. Okay, after getting this, then let's start again. So after doing your first one, okay, do the second one. Then now after doing the second one, you should just be pressing equals, 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 then the discount factors will follow on their own. Do you understand what I said?
No, I don't understand.
Okay. Okay. If you, after doing the first one, you know, the first one you said what? 1 divided by 1.1, bracket closes, raised to power 1. Then you press equals. Okay? Are we together?
Yes, Mr. Papa.
Okay. So now, after pressing equals, whatever you have, divide that by 1.1 again, and press equals and say what you're going to have. Let me see, I have a scientific calculator here. Let me use my phone scientific calculator.
Yes, we get the same, 0.826.
Okay. Now, after that, don't use divide by 1.1. Just press equals. Press equals and see what will come.
Yes, 0.71751.
Exactly. So now, if assuming you have the fourth year, if you press equals again, it will give you for the fourth year, and you press equals again, it will give you the fifth year, and so on and so forth. So that's fast way of calculating it. Yeah. Is that clear?
Yeah, it is. Thank you.
Okay, brilliant. Please make sure all of you are